This is Algebra 2, Lesson 5.4, Reflecting Functions. A reflection is a fancy way to say flip. And we flip functions using negatives. So a vertical flip would be flipping something up and down. And to do that, we just need to put a negative in front of the entire function. To flip something horizontally means to flip it left to right or right to left. And to do that, we will put a negative in front of the x value. So this lesson, we're going to still use our translations. We're still going to be adding and subtracting to move things left and right and up and down from lesson 5.3. But we're also going to incorporate negatives to slide it and flip it at the same time. And just to give an example of how each of those look in picture form, a linear function, if you have your parent function here and you were to flip that down, I'm going to go colorful. And you were to flip that down, so putting a negative in front of that function would flip it this way instead. And the thing about the linear function is if I flip it down by putting a negative in front of the whole thing, it's really the same as flipping it sideways, which is putting a negative in front of just the x, because the whole thing is just an x. So a vertical flip and a linear flip look the same, a vertical flip and a horizontal flip look the same in this context. With a quadratic, we'll go back to the regular parent function. We have our u shape. And if I were to flip that down, it would just be that u shape now upside down. Right? These ones flip down, flip down. If I were to try and take that u shape and flip it sideways, so horizontal reflection, this one would flip to here, this one would flip to here. That, because it's symmetric, would actually just be a mirror image, so it's not actually possible to horizontally reflect that quadratic. You could reflect it over the x-axis, but we're not going to worry about that. So our quadratic reflections will only just be vertical. So putting a negative in front will flip that u-shape down. And I'm going to jump to the absolute value because it's actually kind of the same deal. That V shape is symmetric, right? So I can flip that V shape down by putting a negative in front of the function, right? He flips down, that V shape turns upside down. If I try putting a negative inside my bars, because it is a symmetric function, this one on the right would flip to the left, this one on the left would flip to the right. It doesn't actually change the look of the graph. The one that looks and has the best actual horizontal reflection would be the square root function. So your regular square root function looks like that. And I like to think that it's almost the same shape as the symbol, right? I have this arrow pointing up and to the right. My square root symbol points up and to the right. So the shape of the graph looks a lot like the square root symbol. If I were to put a negative in front of my square root, that shape flips down. So now I'm going down instead. That is my vertical reflection. And now for my horizontal reflection, if I put a negative inside, that's flipping it left and right. So on the right here now flips to the left. So it's going to point this direction instead. So if I'm trying to point it down, I put a negative in front. That's my vertical. And if I'm trying to point it left instead of right, that's my horizontal, I put a negative inside. So the other three, we're going to focus primarily on vertical reflections. We're only going to really look at the horizontal reflections on the square root graph. Moving to the examples. Describe how g of x equals negative quantity x plus 2 squared minus 4 relates to the parent function f of x equals x squared. I see three things happening. I see a negative in front, I see a plus 2 inside, and I see a -4 outside. So the negative is the new thing we were talking about on this page. And to do a negative in front, right, in front, that's going to be a vertical reflection. This is just... We can also say flip down. If we want to be less technical, I will accept either vertical reflection or flip down. The +2 inside comes from the previous lesson. Adding 2 inside of a function next to the x would be a horizontal translation. So I can be really technical and say horizontal translation. I'm not even going to fit all these words. Translation 2. Or I can be less technical and say left 2. And I need to make sure, that'd be a -2. And I need to make sure that because I'm having a plus in there, it's moving to the left. Last thing is the -4 at the back. That is going to be the vertical translation. I don't really feel like writing all those words. But vertical translation, -4, means down 4. So super technical, vertical reflection, horizontal translation -2, vertical translation -4. Less technical, flips down, slides left 2, slides down 4. Letter B. F of x equals the square root of x. Write an equation for a horizontal reflection and translation up 3 units. So I need to flip it sideways, and I need to slide it up 3. So I'm going to start with my square root of x. If I want to flip it sideways, I need a negative in front of the x. And if I want to slide it up 3, I need a +3 outside of the function, so way back here. And to make sure it's clear that it's outside, I like to add parentheses. Those aren't necessarily necessary. We'll throw y equals in front, and that looks like a good equation. I have a square root that got flipped sideways and then slid up 3. It doesn't ask me to, but I'm going to sketch a little thingy here. The normal one is going this way. So my translated image is 1, 2, 3 units up from the original vertex. It's now here, and it's pointing left instead of right. And the last one, the graph at right shows a parent function and its translated image. Write an equation for the image. So I know that that is an absolute value function. I recognize the V-shaped graph. I also see the parent function right here. So I know I'm going to have some bars in my answer. So I'm going to go y equals, and I'm going to fill in the template, leaving some spaces. So the vertex of the original is at the origin, and I need to move it to the vertex of the new one. And I can see that I have an upwards V, and now I have a downwards V. So I need to flip it down. In order to flip a graph down, all I need is a negative in front. Then to slide it to the left, it goes to the left 4 units. I need a +4. And then I need to slide it down 1 unit. And to slide it down 1, outside I need a -1. So the negative flipped it down. The +4 slid it to the left 4, and then the -1 slid it down 1. And that is it. Good luck on the exercises, and please let me know if you have any questions.